So this is a follow-up video of my last video, a web server to control GPIO on a Raspberry Pi with WebSockets. And I got quite a few comments on that video, people wanting to do other things with the web server. In particular, they wanted to, like read analog values and all other types of things, and they wanted to do it in Python. And so I thought I'd make this video on showing how to set up a communication link in Node.js and communicate to a Python program and have the Python program to do all your controls and just use Node.js as a web server front end for the Python program. So that is what this video is about. So I have a web browser here. I have two windows open up here on the top, and I'm going to start Node.js right here, and then I'm going to go to my web page, and you'll see we have our GPIO pins. I've added a video window here that's taking a look at our LEDs, and got a keyboard, a volume control, and a text box down here, and we'll talk about those later. Anyway, so right now it's not going to do anything because Node is no longer controlling the GPIO or doing any of the logic for the feedback or anything. So it is actually a Python program here, and I got this Python program up right here, and so I'm going to start this up. And now you can see our GPIO pins working. I could go ahead and hit a button here, turn on an LED, and toggle it on and off. So it's just like the other project where we can control our GPIO pins. And you can see it displaying right down here below. There's a little bit of lag here. I'm actually using another Raspberry Pi with an HQ camera on it. And I'm using a program called MotionEye to basically stream video from the camera, and then I'm just importing that into this web page here. But there is a little bit of a time delay between the time that the LED comes on and where it shows up here. But it is instantaneous, actually. Anyway, that's what we're going to talk about, is how to do this and how the program works. And so if you're interested in this, you could go ahead and watch on. So to run this demo program, just follow the instructions in my previous video. I've already covered how to install Node.js and that, so I'm not going to do that here again. But it does work with the latest versions of PiOS. I'm using the May 7th, 2021 version. I recommend that you use the full desktop version, but you can use the light version too. It works too. And then for Node.js, you want to go to the website and download it. I still haven't gotten 14 to work. I haven't tried that hard to get it to work though, but version 12 does work, I know. So that's what we're going to use here. And you want to go to the previous releases here, go to Node.js, and then download the version for your Pi. And then likewise, if you're using the Raspberry Pi 0W, you actually need to use Node version 11. And the reason for that is later versions of Node no longer support the ARM6 processor, which is what the Raspberry Pi 0 uses. So now that you have Node.js installed, it's time to run our demo program here. And so let me bring over the documentation here. So you're going to want to go to your SSH into your Pi. I've already done that. And we'll go to our downloads folder. We'll do a directory listing. And we want to go ahead and remove our old main.zip file. And then we want to get the new one. And we do that by going to this link here, do a wget command. Okay, we have it. Let's take a look. So next you want to go ahead and unzip that. Let's do another listing. And now we got our new program here. So let's go ahead and change directories to that. Do another listing. And just like before, we're going to copy that over to our web server folder, but we're going to create a new folder to put it in. We already have one called GPIO, and we're going to create a new one called WebGUI. So let's go ahead and make that directory. And then we need to copy our files over there. And then let's go to that directory and do a listing. And there's our program. So just like before, what I showed you before, you just need to go ahead and run the program now. So let's go ahead and get our other window open here. So you have to open up two SSH sessions to your Pi, one to run the Node.js program and the other one to run the Python program. So let's go ahead and do that. Node web server.js. And now our web server is working. And then you just need to run the Python program. So let's do another listing here. And we want to run txrx here. Python 3, txrx. And now we're running. So we'll go over here and just confirm that. Yep, it's working. So let's talk a little bit how the communication interface works between the Python program and the Node.js program. So I'm just going to stop the Python program here. And then we're going to use a program called netcat to talk to our Node program. So let me just go ahead and expand this out a little bit. Actually, let me clear the screen here first. So the demo program actually has two COM links built into it. One is from Node.js to the Python program, and the other one is a communication link where I can talk to it directly to Node through my laptop. So we're going to use a program called netcat to do that. And first of all, we got to get out of the Raspberry Pi shell here, so I'll just hit exit. And so now we're back to my laptop here, and then we'll paste in this command. And so netcat is the program. We're telling it to use UDP, and we're telling it to go to the address of the Pi, which is at 192.168.18.105. We're going to talk to the Pi on port 3000, and we're going to receive data back from the Pi also on 3000. So we'll go ahead and execute that. And then we'll just hit enter, and you'll see syntax error here because we didn't send it a valid command. So let me just go ahead and push a button up here. And you can see it comes back and it tells me that I hit GPIO 26T, and I sent a JSON value of 1 to it. And these are what they call JSON pairs, a key value pair. And that's the way we are talking to Node.js. And JSON notation is very easy to use with web pages, and so that's the reason why we're using that. So let's say we want to change the feedback of the GPIO 26 toggle switch here. All we have to do is just basically echo this GPIO 26t:1 command, and that will tell us to tell Node to turn on the feedback. So let's go ahead and do that. And it turned on the feedback. Likewise, if we want to turn the toggle switch back off, we just send a 0 instead. And it turns it back off. So that's basically how the communication link works. It sends a JSON pair telling you what button you pressed, and then it sends and then to change that feedback, you just go ahead and send another JSON value back to the Node program. And then like the volume slider here, I'll go ahead and move it up, down. You can see it's sending a bunch of values, and the JSON key is A1. That's referring to this slider, and that's, if you look at the HTML program, this slider has an ID of A1. And so if we wanted to change the value of the slider from 77 to 20, we would just do that by just sending it back. So let's go ahead and do that. Go back here and change the 77 to a 20. And now our slider is moved to 20. Likewise, the serial port here. We can send a message to our laptop, so I'll just type in hello, hit enter, and here it comes back. It says S2, and the value sent was hello with a carriage return. So if we wanted to send something to, let's say, this text window here, it's S3, so we would just type in curly brackets, quote, S3, another quote, colon, and then another quote, and then the message, and we'll just say, hello world. And we'll put a carriage return on it too. And there you see, we have hello world that showed up into this window here, and we can go ahead and send another one. And we can send another one. And so they're just showing up here, and then we could hit this clear button and clear it out. And then if we wanted to send, like this is an input selector, we'll go ahead and hit that button. That's D32. So if I want to change the feedback of that to the active state, I just send it a D32 1 instead. And it made that feedback high. And likewise, if we wanted to make it go back low, we would just send a D32 0. And the feedback is low again. And so that's basically the way it works. Very simple protocol. And that's how we're talking back and forth to the Python program. So the only thing you'll need to change in the program to make it run for you is in the webserver.js file. If you want to talk to the Node server with your laptop, like I did with Netcat, you're going to want to change this line right here. This is pointing to the address of my laptop, which is 192.168.18.34. You'll need to change that to whatever the IP address of your laptop is. And then the other thing you need to do is, before you start Netcat, you need to enable port 3000 to pass your firewall, because if you don't, Netcat won't get any of the messages back from Node. Anyway, that's basically it. I hope you find the project useful. If you do, go ahead and give me a like. That will encourage me to make more videos. And you have a good day.